Okay, hello. So, a friend of mine asked me for a code reveal. He is starting to learn Python, and he shared a very simple script, and I'm basically going through the script and playing around with it. So it's nothing that's not really fixing anything or getting anywhere better. Just see what we can learn and share from this simple script. So this is what he shared. It's something very it works pretty well. It's a calculator. So in line 1 it asks the user using the Python input function to enter something, to just type something in the keyboard, hit enter, and this something is passed as an argument to the float function, which will transform this something into a number, right? A float number. This is saved in one variable. Then we have another variable which takes the operator. Then we have another number which is basically the same of the line 1. And then we have a structure of if, else if, and else to deal with this thing. So this is how it works. So I can type 40, I can type plus 2, and it gives me the expected result. So if I'm gonna change this code, I really want to make sure I'm not messing up this logic because it works really well. And that's why we have tests. So if I was able to write a test to make sure I'm not messing up with the most basic thing we have here, that would be wonderful. It happens that this code is not very easy to test. It's kind of packed in a lot of instructions, and we don't wrap these instructions into something like functions or methods or whatever. So that's the first thing I want to do. I want to ask the computer to help me not to break this code, and for that I need tests. One way to get there is to wrap this bit of code here in a function, and then I will expect the result of this function, given the first number, given the operator, and given the second number, to be always the same. Not the same, but like to be something I expect. So my idea was first to start to wrap this as a function. This function will be my calculator. You can name it whatever you want. And then I will just use the same variable's name, so we don't have to change a lot of code from the start, right? And now we have something that might work, but of course I have to call the function. So I have to call the function, and let's say I'm calling with the same argument, so I don't have to retype then. So that's it by now. So I haven't changed much here, but it's difficult to test the output of this function because it doesn't return me anything. It just prints stuff in the screen. So it would be better if we can print the result that we return, and instead of use this print here, we could just return the value. Okay, so let's return, and return. So now instead of printing, the function returns the value, and I print in my last line, line 17. Okay, I'm gonna save it. There is something wrong. Oh, here is wrong because when I was changing the input by the return, I removed the quotes. Okay, there are some minor things over it. I indented, so there's more spaces on these lines than it should be. I can use black. Black is an out formatter for Python. You can look for it online. It will just fix the formatting for me, and now no errors found. Okay, so I haven't changed much, but what's good about this structure, like it still works as as it used to work before. Oh, I cannot enter comments here, so let me just leave the editor and okay. So it works just like before, but the good part is that now I can write some simple tests to make sure the calculator works as expected. So I can write, for example, assert the calculator function given, for example, 40, given this string here, and given 2 will return me 42, right? It's okay, it's something I can fix with black, right? Okay, and now if I mess up my calculator, I'll get an error, and that's what I would like, because I don't want to mess this up. So I haven't messed it up just yet, so it still works. But if I come here and for whatever reason I said, okay, instead of this you add +1 here, just let's say I was distracted and left this +1 as an error, as I created a bug in the application. If I try to run it, let's see, it shows me it's an assertion error that says the calculator is not working as it should. But there's something annoying here, like it really asks me for information before running the test. And I would like to know that it's broken before I really enter all those things. So I can move all those things to the end of the file. So, oops, I just did something wrong here. So, first I have my function, then I make sure this function works, and then I start enter things. So now it's still broken, I haven't fixed the bug, but it gives me the assertion error right from the start, which is good. It saves me time. I don't have to type 3 things to know I've broke the code. Okay, so that let's get rid of the bug. So now it works, and this is what I have. Of course we can like write more tests. For example, we can say that given 44, given the minus sign and 2, we still should have 42. Let's say here that if we give 21 and multiply by 2, we should have 42, and 84 by 2, we should have 42. So we are just creating more tests, which is good. It still works great. I'm gonna just go back to the code. Okay, so here we have some repetition of code. I haven't changed much the code. I just wrapped it in a function, and now I see that line 19 and line 21, they are basically the same. So I was thinking maybe we can write another function to wrap this and avoid repetition. So this is something that comes to my mind. And then we can just call that function here, and again here. What's interesting about that is that if I have to change something, for example, if my user complains that maybe this label is not right, it should be something different, I can just change it here once, and the change will happen when the user enters the first number and the second number. So avoiding repetition is good, not only because you don't have to type the same thing twice while you're coding, but usually makes your code easier to maintain throughout time. So if, for example, I have to change my calculator to work just with integers and not with floats, I just change it here once, and I don't have to change it in line 23 and 25, right? So that's the point, right? Something that maybe it's just me, but here we have number abbreviated, and here we have number in the full form. So I think I would just leave all of them the same, just so we have number everywhere. Okay, so done. First number. I can use operator here just to be more readable. I think it doesn't save much, but it says it doesn't save much typing for us, but it says a lot more about what we are doing. I just mess up here, I guess. Okay, operator, enter the operator. I think we had this D, but it's okay. Okay, so here's what we have now. Same if else structure, but it returns a thing instead of printing the thing. We have a function to ask users for numbers. We have a couple of tests, and we have the same logic here. I just rename it some variables. As I wrote tests, I feel pretty confident we can change this bit of the program. And I would like to change it just to avoid this repetition here. If you pay attention, line 3, 5, 7, and 9, they are basically the same thing, just changing the operator. It's easy to mess up, and it's something of a repetition. On the positive side, I think this function as it is, it's already pretty much readable, and as you know, readability counts in Python. So first thing is that, like, if my function happens to be executed with the plus sign, it will get to this return, and once the function returns in Python, the function execution is over. So actually we don't need the else if here, we can just use if, because if the evaluation happens to execute line 3, there's a return there, so nothing will be executed beyond that until the end of the function. So we can clean up our code a little bit like this, and we don't even need this else here, because if the interpreter, the execution, gets to line 13 without reaching any return, that's all we have. We are left with. So this is gonna happen. So this is last code. I think it's readable, but maybe I don't know. So if the operator is plus, you return this. If you return this, you don't execute all the rest. If the operator was something different, you never execute this, and you get to line 4, which is blank, then line 5, and you repeat the same logic. Okay, I think this is the most readable version of the code. I don't think we can get any better in terms of readability, maintainability, and stuff. This is looks good for me. It still works, I guess. Of course, I'm a dumb user. I just test with the same values, and probably this is not a good practice. But I would like to do something else here, and this is just out of fun. So I hope you all have fun while learning Python. I have a lot of fun, and maybe I'm just silly. But anyway, sometimes when I have like this sort of repetition, I have to check something with an if. And this if evaluated to true, just change a minor thing in the value it returns. Sometimes I like to use in a dictionary. Again, to be honest, I don't think it's the best approach for our calculator there, but I think it's a strategy worth sharing. But before sharing, I just wanted to tell you something about numbers in Python. Let's say we have numbers. Let's say x is 42, y is 21. What else? Z is 2. All these numbers, they have special methods, which is kind of hidden in Python by the double underscore. We call dunder in the Python world because, I don't know, we have fancy names for silly things. But when you do, for example, y multiplied by z, it returns 42, as you should expect, but it's actually calling the multiplication hidden method of every number in Python, and it's calling this method, which is like a function belonging to an object, to a class, to, in this case, to a number, with the other part of your mathematical operation as the argument. So if I call y dunder mu and pass z, we should expect the same thing. And we have those things for all the operations. So we have x add, for example, 0, it gives me 42. I'm not just repeating the number. If I put a different thing there, it happens. We have, for example, y sub 19, we get 2, and the division is a little bit difficult to find, so it's called true div, I guess. Yes, it's there. So what I'm thinking here is that I can choose the method to call in the number based on a string, and that's when I think dictionary might actually help here, because I can map strings to methods, and then I just call the method the map tells me to call. So what I'm implying here is that I'm mapping the plus sign to the first number method add. I'm not calling the method. If I was to call the method, I would like put the parentheses and some value here. That's not what I'm doing. I just assign it the plus sign in a dictionary to the method. I'm gonna call the method later. I can do the same with this subtraction. I can do the same for the multiplication, and I can do the same with true div, right? Okay, now I have a dictionary, and I could choose what method to use, calling this dictionary and passing the operator as a key. So if the key is a plus sign, I will have the add method of the first number, and then I just pass the second number, and the result will be first number plus second number. The problem here is that if the user types something that I'm not expecting, this will raise me a key error, and that's not good. We're gonna fix that later. So here we can do then a return that will be the method. Let's say the user typed the minus sign, so the method at this time of the code is first number dot dunder sub, and then I can just pass the second number, and then it's what I expect, right? I'll just let this comment here because I'll use later. So I don't think this is more readable than what we've got, but it's basically because what we've got was very simple, and maybe sometimes you have a similar situation with more complex stuff, and maybe this is helpful. So this, I think it works. So if I put 40 and the operator and 2, it works, but of course there's a problem that this message that something was typed wrong doesn't happen anymore, because if I type something silly here, for example, we don't have this operator, oh, and there's a typo, this operator in our implementation, then it's a key error, and the user will kind, oh my god, what this thing is doing. There's a lot of things I wasn't expecting in my screen. So we can fix that, and we actually should fix the typo operator. Oh, it looks way better now. So One way to fix that is to use the try and except that it's traditional in Python, and then here we return the invalid input. But I think this is too much for a dictionary. For a dictionary, we have better ways to do it, which is using the get. So the get will try to find a key value pair in the dictionary. So the argument here is the key, but if it doesn't handles to find this key, it returns none. It throws no error but returns none. So I can here say if not method, which means we weren't able to choose a method from this mapping dictionary given the user input, then we return the invalid input. Otherwise, we return the method using the second number as an argument. So let's see how it works. No error, it means we haven't broke the thing. And now it should work. Yay, great, it works. We still can, oops, where is my file? Okay, not sure what happened. I feel like the one-line thing, we can do, let's say we can do return method, and we can just like wrap those 3 lines in one. It will look like something like this. It's basically the same thing. And again, I don't think this helps in terms of readability, to be honest, but sometimes you might see this code is the same thing. It's basically return method passing the second number as an argument if the method thing is not something like none, which it might be the case. If the method thing is something like none, then we return this string here. So I don't really think this is better than we had before, but this strategy might help you here and there. Okay. We should have added a test here for something not expected. So if the user says X, we should expect the invalid input string. This will help me to catch the error when I get a key error. But I think that's it. I mean, we managed to make things worse, but hopefully you've had the chance to learn something new. Okay? Hope you like it, hope you like studying Python, and count on me to help you. Bye bye, see you.